All right, next problem, we have a random sample of 600 observations produced a sample proportion equal to 0.45. Find the critical and observed values for Z for the following test of hypothesis using a significance level of 0.025. So this is a proportion, okay, proportion. So we're going to use Z here. Let's go ahead and write that down. Okay, let's see what we've got. We've got a P is equal to 0.39, and then for our alternative hypothesis, P is greater than 0.39. So for the greater than, you're pointing to the right. This is a right-tailed test. Okay, and your significance level is 0.025. So you want to find the value of Z that has 0.025 in the right. Okay, the only issue with that is that when you do the inverse norm command in your calculator, you want the area to the left, and then you want your mean and your standard deviation. So to get the area to the left, since this is 0.025 in the right side, we're going to go 1 minus 0.025. Okay, that'll give us, I believe, 0.975 for our area to the left. Okay, so we're going to go second vars or distribution, inverse norm, 0.975. Then we have standardized our scores, so we're always using 0 and 1 for our mean and standard deviation here. So that's going to give us 1.96, and that is going to be our Z value. Okay, so this will be 1.96. Okay, so that's roughly right here, 1.96. Okay, that is our critical value, which means anything to the right or a greater than, a test statistic that is greater than 1.96 will be in the rejection region. Okay, so then this was inverse norm, 0.975, 0, and 1. Okay, so that's our rejection region here. Let's go ahead and get the Z value. So we have a sample size of 600. We have a sample proportion p hat of 0.45. Okay, and we want the critical and observed values. So what we need to do here for our Z is p hat minus p over the standard deviation of p hat. So the standard deviation of p hat is going to be the square root of p times q over the sample size. So for us, that is a p of 0.39. Okay, if p is 0.39, then q is going to be 0.61. No. Brain fart here. 0.61, yeah. And then our sample size is 600. Okay, so let's go ahead and get that value. So we get the square root of parentheses 0.39 times 0.61 divided by 600, close the square root. So we get 0.0199. Okay, let's go ahead and plug that in. So this is our denominator. Our p hat is 0.45. And our p is 0.39. So 0.45 minus 0.39 divided by 0.0199 gives us 3.015. Okay, where is that on this curve? Well, that is way over here in that rejection region. Basically right here, 3.015. Okay, we're in the rejection region, so we are going to reject the null hypothesis. That actually, we were just going to find the critical and observed values, but we're going to go through the whole thing. So we will reject the null, okay, because 3.015 is greater than 1.96. We're in the rejection region. If we wanted to use the p-value approach, okay, that means we have to get the probability of 3.015, which means we need to find, using normal CDF, the probability. So we would go normal CDF. Our lower limit is going to be that 3.015. Our upper limit is going to be 99. So that's going to give us 0.0013. Okay, so we're going to take the p and we're going to compare it to our alpha. So our p is 0.0013. Our alpha, our critical significance level, 0.025. And then we say p is less than alpha. So when p is less than alpha, we reject the null. When p is greater than the alpha, we fail to reject.